Hi everyone. So this is a lesson that Miss Sinclair and I would have taught you today if it wasn't for the 2-hour delay. So today we're going to talk about graphing exponential equations. So in your unit packet, it is the page that looks like this. We're going to actually skip the do now, and we're going to start at this portion here and look at graphing exponential equations. So an exponential equation is when there's a variable as the exponent. So for example, if we take a look at the first question here, it says to graph y equals 2 to the x. So now this is an exponential equation because we have our variable, which is the x, as the exponent. So to graph this, it's pretty straightforward. We're going to graph from -3 to +3, and we just want to get a general idea of how the graph looks, how all exponential equations look. So right now we're going to go ahead and substitute -3 in for x, -2 in for x, and so on, and see what values we get. So we can easily do that. Let's go ahead and do 2 to the -3rd, 2 to the -2nd, 2 to the -1st, and so on. So I'll give you a chance to fill in this column. Okay. 2 to the -3rd, well, that's the same thing, and I'll just put that over here on the side. That's the same thing as 1 divided by 2 to the 3rd, and that's 1/8. 2 to the -2nd, well, that's the same thing as 1 divided by 2 to the +2nd. That's 1/4. This would be 1/2. Anything to the 0 power is 1. 2 to the 1st is 2. 2 squared is 4. And 2 to the 3rd is 8. So now if we were to graph this, at -3, we're at 1/8, so I don't know, it's pretty close to the x-axis, but not quite on the x-axis. This again, pretty close. Starting to move up slightly. Then 0, 1. Now it's starting to grow pretty fast. And at 2, it moves up to 4. And then at 3, it grows even further to 8. Okay. So we have a kind of a rough idea of how it looks. And let's connect. And we'll put arrows at the end. Okay. Now the calculator will graph this for us as well, so let's take a look at that. So in y1, let's go ahead and put in 2 to the x. Just take a look to see what it looks like. So it looks the same, exactly like ours. Notice how it goes through the point 0, 1. So we could also look at the table of values and see if they match. And if we notice from -3 to 3, it's the same table of values. These are just in decimal form, but they are equivalent. So here are some questions about properties of exponential equations. First one says, will the graph ever touch the x-axis? Why or why not? Well, let's take a look. If we keep going decreasing, notice how it's getting very, very, very small, getting close to 0. This here, 9.8 e to the -4th. That just means it's like really, really small. But it never does actually touch the x-axis. No matter what number you put in for x, it can never be 0. So no, it will never touch the x-axis, and the x-axis is actually going to be an asymptote. So we've learned about asymptotes before. That means it's a line that will get very close to the line, but it just never touches. So no, and the x-axis is actually an asymptote. So that's something you want to write down. In which quadrants does the graph 2 to the x lie in? Well, we could see that that's in quadrants 1 and quadrants 2. So again, these are just properties about them. You can look at it from the graph. So 1 and 2. And now we want to know the domain and the range. The domain, so those are our x values. So if we take a look, we have arrow going to the left, arrow going to the right. So it's actually all real numbers. So the domain is from -infinity to +infinity. So we could express it this way in interval notation. Okay, our range. The range would be the y values. So let's see what our smallest y value is. So the x-axis is an asymptote. So I'll just put this blue line here, meaning that this graph will never touch that blue line. So the smallest y value is very, very close to 0, but it doesn't include 0. So the range, like I said, gets close to 0, but doesn't include it. So 0, and the arrows go up all the way up, so it's from 0 to infinity. So that would be the range from 0, doesn't include 0, all the way up to infinity. Okay, so why don't you go ahead, I'm going to pause the video, and you fill out this table and take a look at the graph and see some similarities, some differences. So at this point, hopefully you filled this out on your own, but here would be the answers. So again, we're going from -3 to +3. Now hopefully you noticed that there was a common point that both the graph 3 to the x and 2 to the x went through. And that common point was 0, 1. So if you notice, both of them went through this point right here, 0, 1. Let's go back a page and look at 2 to the x, and again it went through that point 0, 1. And that's a property of an exponential equation graph. That will always happen. Anything to the 0 power is 1, so 100 to the 0 is 1. -8 to the 0 is 1. An exponential equation graph will go through the point 0, 1 as long as there's no shifts or anything. So now you should have noticed also, let's graph maybe both of them. Put both on the same graph. So 2 to the x and 3 to the x. So we'll graph both of them and see how they look. So here's 2 to the x, and here comes 3 to the x. Notice how it comes in a little bit steeper. If I did, let's try 12 to the x. That would be even steeper than the other two. We'll see that in a second. And there's 12 to the x. Okay, so as the number increases, the more steeper it will get. Okay, so why don't you go ahead now and try graphing a half to the x, 0.5 to the x. So I'll give you some time to do that. Pause the video and try it on your own. So this is what your table and graph should look like if you did it correctly. Notice how the graph still goes through the point 0, 1. It's just kind of in the opposite direction. The graph is now decreasing where the other ones increased. So let's take a look at the graph 2 to the x and 1/2 to the x. We'll look at both of them together. So this is 2 to the x, it's increasing, and 1/2 to the x is decreasing, but they both go through the point 0, 1. 1/2 to the x and 2 to the x are reflections of each other in the y-axis. So what's the difference between the two? So if the base is greater than 1, so we saw like 2 to the x, 3 to the x, 8 to the x. So if the base is greater than 1, then the graph increases. But if the base is between 0 and 1, so 1/2, 1/4, so on, the graph decreases, as we saw with this example. So here are properties of exponential graphs. Pause the video so you have some time to copy down these 4 properties. Okay, so now we're going to look at the parent function of a graph, so like 2 to the x we'll say, and we'll look to see what happens when we shift some things around. What I would like you to do for the first graph, y equals 2 to the x, is put in the asymptote. And what we're going to do is just do a very, very rough sketch. We graphed them a little more precisely before. So we know 2 to the x will go through the point 0, 1. And it's going to look something like this. Okay, again, this isn't completely accurate. We're just doing a rough sketch. Well, the graph y equals 2 to the x plus 1, well, that's going to shift everything up 1 unit. So here is that special point, that point 0, 1. Well, now that new point is going to be at 0, 2. So we can go ahead and draw in the new asymptote at y equals 1. And then again, we'll just do a very, very rough sketch of it. It's now going to go through the point 0, 2 and look like this. So again, let's just make a note that this point is now 0, 2. So the point right here. Okay, and very similarly, if our point was at 0, 1, but now we shift everything down 1 unit, okay, well now our new point is going to be at 0, 0, and the asymptote will now be down 1 unit, so it'll be at negative 1. So we can go ahead and draw that in. At negative 1, that is where our new asymptote is. And again, we'll just do a very rough sketch. It goes now through the point 0, 0, and would look something like this. Okay, so just make a note that that new point is 0, 0. So I think you get the idea. We've done vertical shifts before. Now let's go ahead and look at horizontal shifts. So, okay, if we have y equals 2 to the x plus 1, I think you'll probably have an idea of what happens based on your knowledge of those type of shifts, but let's see. Go ahead and put in 2 to the x, and let's go ahead and put in 2 to the x plus 1. Let's take a look, and I think you'll know what happens. So there's 2 to the x and 2 to the x plus 1. Notice how it was shifted to the left 1, and I think that will make sense based on all the other parent functions we've done in the past. Okay. So if our point here was at 0, 1, well then the new point is going to be at negative 1, 1. Okay, and it would look like this. Okay, so that new point is negative 1, 1. And the asymptote would be at the x-axis. Nothing changes there. Okay, y equals 2 to the x minus 1. I think you'll realize it moves to the right 1. So again, the asymptote is on the x-axis. And if the point is normally at 0, 1, but we're moving to the right 1, okay, well that new point is now going to be at 1, 1. Okay, and it would look like this. So again, let's write down what that new point is. 1, 1. Okay, so here's kind of the general rules for the shifts. If we add a constant at the end, it's going to be a vertical shift up. If we subtract a constant, it's going to be a vertical shift down. Okay, in the parentheses, so if we're adding to the exponent, it's going to be a horizontal shift to the left. If we're subtracting in the exponent, it's going to be a horizontal shift to the right. So now this should make sense based on all the other parent functions we've done in the past. So we're going to actually stop right here and save the next page for the do now on Monday. Okay, so hope everyone has a great weekend, and we will see you next week. Bye.